All right, so continuing with connectors. I've got a few more of these little ones to do and then we can get into the big stuff. So this one is, well, first, any questions from last time? Everything makes sense? Okay, so this one is an RJ45 connector. Typically, this will be put onto some sort of Cat5 cable or Cat6 or something like that. We'll talk about that in a minute. Primarily used for networking, computer networks, Ethernet networks. However, also used for lots of other things. For example, CAN bus for D&B amplifiers. Also can be used for really any sort of thing that you like that could benefit from twisted pair technology like that. So like Aviom, which is a company that makes systems for it's primarily monitoring systems, like personal monitoring systems for audio. They have their own little way of pushing sound through these sort of connectors in multi-channel. It's not a traditional Ethernet network. You plug that into your computer network and it's not going to work. It's its own little thing. But there's lots of other things like that. So there's like CobraNet and EtherSound and all these kinds of things that will run with this. There is Neutrik has made a kind of essentially a barrel for these. They call it EtherCon, and it's like the same size as an XLR. You've probably seen them. The issue there is that really those little RJ45s are really not designed to be connected and disconnected a whole lot.
7 times.
Yeah, it's not very often. It was envisioned that maybe you'd patch it a few times in some sort of network patch panel, but largely you would leave it untouched. So using it in a production environment like ours can be very volatile. And what happens a lot, the first thing that happens is that little tab that locks in place, that busts off. The other thing that can happen is if you damage the little ridges on the bottom where the wires connect in, if that gets bent or somehow distorted, and then you try to put it into an actual connector or a switch, you can damage the switch. In other words, you can bend the pins inside of that switch, and that's very, very difficult to repair. So what the EtherCon attempts to do is you essentially bust the tab off to begin with. Okay, and then you put this little barrel around it, which is the same size as an XLR, therefore it locks the same way as an XLR. And it theoretically prevents or attempts to prevent the connector from being damaged in that way. It allows you to connect it and disconnect it, more often, and prevents those pins from getting distorted and warped and things. So that's really great. Not everything has that, but there's the actual Neutrik part of it is literally just the barrel. You still have to bring your own RJ45 connector, and there's a couple different versions of it. One that allows you to wrap it around one that's already been terminated. In other words, the boot has kind of a slot in it, and you can kind of put it around without having to cut off the connector. And then there's another one that you would put on while you terminate it. So you put the boot on first, then put the RJ45, and then put the barrel over it. Anyway, you'll see those in the shop and things. So that's a much preferred way of dealing with it. And anytime you've got a situation where maybe you can't put an EtherCon connector in it, like the receptacle for the device doesn't have that barrel on it, you might at least have it on the other end and have some sort of a patch panel that you can make. So you're patching with the EtherCon, and the connection to the actual device is only made once with a little jumper or something. And that's a little bit better way to go. This one is called the RJ11. It's very similar. Primarily used for telephones, analog telephones. It has as many as 6 pins on it. The telephone really only uses 2 of them. So you can get, this is the way you can get more than one line on a telephone in the analog domain anyway. Once you go to digital, you can code them digitally. But if you want, you could get up to 3 analog lines on one RJ11 connector. So we use this for phones. A lot of times we have to ring phones on stage. Sometimes it's more convincing to actually have the real phone ring as opposed to play a sound effect of a phone ringing. There's little devices you can buy that will let you ring a phone. And the most popular one is called a telecue. And it uses the middle 2 pins to actually ring the phone. And then the outer 4, the 2 on either side, are used for other things. There's like a remote control connection there. One of them, it can be used to actually power a buzzer or something. And you can build little breakout boxes to ring multiple phones and stuff like that. So you actually need a full 6 conductors, crimped onto that thing in order to leverage all of its capability. Whereas most telephone cables will only have 2, maybe 4. So you got to make sure that you would buy a full 6 conductor one because it can accommodate that much, but you don't actually have to have that many in there to make it work out on a regular phone. Okay. Another one that kind of breaks down after a while, but again, and it was never envisioned that you'd be messing with it a whole lot. You plug your phone into your house and mess with it. I mean, you don't touch it for years, So those will break a lot too. We're always having to re-terminate those. So these are just, these ones here are a couple of, you're familiar with these, couple of versions of USB. There's lots of others. So universal serial bus used for all kinds of things that plug into your computer. You're familiar with that, I'm sure. Also, this was one example of FireWire. Most FireWires you see these days are going to be FireWire 800, which has more pins and the connector is kind of square-shaped as opposed to this one, which is kind of D-shaped. The reason I want to highlight this particular one is this is the FireWire 400, and it turned out this had a particular weakness in its design from the perspective of sound devices, because while the outside of the connector is keyed, in other words, it's sort of like round on one end and flat on the other end, the inside of it is not. And depending on what sort of receptacle you were plugging this into, it is possible to put it in backwards if you were really determined. Because in some cases the thing that captures it was kind of spring-loaded and you could jam it in there, and because the inside of it was not keyed the same way, it'll take it either direction. Now the problem there is the 2 there's 6 pins in here, and the 2 ones on the outer edge are power, and the other 4 are data, which means if you put this thing in backwards, you're putting the power into the data line. And I have seen personally, and even done that myself, fried many audio interfaces for computers that way. Just completely destroying the interface board on them doing that. And it got bad enough where the manufacturers of audio interfaces were really just finally says, look, just don't hot plug them. Even though FireWire was designed to be hot pluggable, they finally said, just don't do it. It's not worth the risk. And they would say, just shut the computer and the device down and everything, then plug it in, make sure it's all good, and then turn it on. You can avoid that problem of, because sometimes even if you're putting it in the right way, if you just kind of like wiggle it in sideways just a little bit, as it's kind of finding its way in there, you can kind of temporarily short that power into the data just very easily and cause all kinds of problems. So that problem was sort of solved with the FireWire 800 version. It's keyed differently, and there's only one way you can put it in, and you can't even really put it in crooked in some ways like you can this one. So just watch out when you see this one. Generally speaking, we would prefer, if given the choice between FireWire and USB, we would prefer FireWire for most audio things. Although this is becoming less of an issue, the reason being that USB, in all of its iterations, is theoretically faster than some FireWire, depending, even so. USB 2 and FireWire 400, of those two, USB is potentially faster, and it has a slightly higher throughput. But USB requires a slight bit of overhead in the computing system because the processor that's inside the computer needs to know where all of the I/O devices are on the computer. It needs to know how to talk to them. And normally, they would get what's called a hardware ID, which is like a unique ID number that identifies that little input-output point uniquely to the computer. And one of the things with USB, which is part of what made it so useful, is that you had what was called a USB bus on the computer, and that's what got the hardware ID. But there was a chip there that essentially managed the traffic routing to all of the USB devices connected to that single bus. So all the devices you would plug into that would not get a hardware ID, and there was a little bit of software going on in the computer that would route all those signals, which was great. It meant that you could connect a lot more devices very easily, and you could hot plug them, and it wouldn't be too big of a deal. And there's all kinds of USB devices that are very useful. However, for a while there, we were pushing our computers so much to the limit to try to do audio on them that that little bit of CPU overhead that was required to manage that USB bus to do the audio input and output in the hard drives, that overhead meant that we couldn't do some sound. Like we couldn't have as many tracks or as many plugins or anything, and it was becoming a bit of a problem. So that's one of the biggest differences between FireWire and USB is that FireWire devices get a hardware device ID. Like they get a unique ID in the system, which means, among other things, that there's very little CPU overhead in communicating with FireWire devices. So you free up some of that CPU resources. The other thing that means is that the CPU can actually direct FireWire devices to talk to each other directly because they have they have device IDs. It's like if you have two FireWire hard drives connected to the system, the CPU could just say, hey, drive 1, copy your stuff to drive 2, and that can happen directly. It doesn't have to go through some surreptitious route to do that. Unlike it would have with USB. With USB, it'd have to come in to the system, rattle around a little bit, and then go back out again in order to navigate through the USB bus. And that's not quite the case with FireWire. FireWire is able to go straight. So while the throughput is theoretically higher on USB, in practical application, it's harder to get that throughput because of the CPU overhead. Now, in recent years, that has kind of changed because somewhere in the last 3 or 4 years, we crossed this line where the CPUs are now faster than our ideas, essentially. So even running really complicated multi-track logic sessions, for example, is barely hitting the CPUs now. They're getting so darn fast. So I don't know that issue with USB is as critical as it once was, but you will still see FireWire used far more often than USB in the audio world, and that's why. It's not as big of an issue, but it is still an issue, and that's a lot of the reason why we prefer the FireWire over USB. But so anyway, there's a difference there. And now there's other interfaces like Thunderbolt, which is even better than FireWire in the sense that it gets a device ID, but it also connects straight into the system bus, which is pretty cool, which is why you're able to get so much bandwidth on that thing. So that shows a lot of potential, and now there's this USB-C, is that what they're calling it?
Type-C,
yeah, that apparently solves all of the problems of the universe, but we'll see. Time will tell. All right, so that's all the little stuff. Now we can start talking about the big stuff. Let's see. So by big stuff, I mean everything so far has been fairly low voltage things. This is all line level and control signals and things like that. And that's where we live most of the time. But it's only after the power amplifiers for our loudspeakers that we start getting into big voltages that we have to be worried about. So here's one connector that you might want to be familiar with. This is sort of this connector straddles those two worlds. This is called a banana connector. It is used for lots of things. The thing that you're going to see most often is this isn't as true anymore, but on a lot of outputs of power amplifiers, there's going to be these things called binding posts, which are these holes that line up with the distance of these pins, and you can plug this straight in there. But the binding post can also be screwed, and you can stick a wire behind it and screw it down. You've probably seen that. So that's what this is used for, is that you can use this to interface with the back of power amplifiers. Well, why? because it is versatile in the sense that you could just do bare wire into it in addition to this. However, there's some problems with this. The biggest problem is it's not keyed, which means you can put it in either way, right? It'll go in either direction. There's not a danger here. I mean, if you plug it in backwards, it's not like you're going to break anything. It just means your loudspeaker is going to run out of polarity. So all the times when it's supposed to push out, it's going to pull back. And all the times it's supposed to pull back, it's going to push forward. So it's just, the sound's going to be inverted polarity. Not a huge issue in and of itself, because we can't really hear polarity differences. But if you had one loudspeaker that was in polarity and the other loudspeaker nearby that was out of polarity, and they're putting out the same signal, then you could hear that because they would be fighting each other in the air. So that can be a bit of a problem with this connector. You don't see this too often, thankfully, but every once in a while you might run into some old loudspeakers that actually have binding posts on the back of the loudspeaker too, which mostly you see this in custom loudspeakers that people have made because it's cheap to get those binding posts to put in there. And like, well, I can get cheap banana connectors and put it in. But the really bad thing about that is then the thing that you're plugging into the loudspeaker is this connector, which has two open air exposed contacts carrying a high voltage signal, which is not a super great idea. Because if you lick that, you're going to get a pretty good shock. Okay? So we tend to try to make sure that what we would call the live end of something that's high voltage, that live end is using some sort of a female connector that you would not be able to lick very easily. Okay? So that's a danger with this thing, particularly usually what'll happen is the live end would be the binding post, and then on the loudspeaker end, it would be something else, and you wouldn't be plugging a banana straight into it. But every once in a while you see that, and that's really sketchy. These are also, the other cool thing about these is you can nest them, and by nesting I mean you can stick another one in the back of it. You can set them up and get parallel chains of them, which is cool, but can become sketchy very quickly when you get a whole lot of them sticking out of them and they're not very secure because there's no locking mechanism for these. There's nothing to hold them in place other than the slight spring loading of the banana itself. So it's very easy for these to get kicked out without too much effort. You'll see these also used on a lot of test equipment like digital multimeters. We'll use little receptacles on the meters that banana connectors can sit into. What that's useful for is you can make really easy adapters, like you could make a banana to XLR adapter or a banana to NL4 or something, and this allows you to actually meter the outputs of your equipment to see like how much voltage is coming out of your mixing console or how much voltage is coming out of your power amplifier. And so you'll see bananas used a lot in some test equipment. All right, you can pass that around. The other upshot of those is they're really cheap and readily available. Okay, you can get those lots of places. Radio Shack carries them quite a bit. So there you go. That's one option for a loudspeaker. Here's another option. Here's our good old friend, the 1/4-inch connector. Actually, I'm not sure this is. Let me see if this is truly 1/4. Yeah, it looks like it is. Okay, this is what this is a 1/4-inch connector, though it's a TS, but it'll take thicker wire. Okay, so lower gauge wire, that, which is what you would want for loudspeaker signals. You need thicker wire to handle that. So you sometimes will see loudspeakers that will have 1/4-inch jacks on them for the connection between the amplifier and loudspeaker. There again, though, you have this thing that's fully exposed carrying a high voltage signal, which is potentially not a good idea. So you wouldn't want to lick this either. There's a version of this that looks a little bit different, and I don't actually know the diameter of it, but there's this thing called a 70-volt distributed loudspeaker system. The idea there being, this is primarily used in like dressing room monitors and things like that, where you need to connect several loudspeakers all in a chain to feed lots of different things, but they all get the same signal. You don't want to have that many power amplifiers. There's a transformer that's put on each loudspeaker that's like an isolating transformer. It essentially makes the load of the loudspeaker invisible to the power amplifier, which allows it to be distributed, as far as the power amplifier is concerned, as voltage. And so you don't have to worry about this notion of power output compared to the impedance. So if there are isolating transformers on all of the loudspeakers, then you can actually power several loudspeakers, theoretically unlimited, in a chain, as long as they don't need to be really loud, which usually they don't. The upside to that is, aside from being able to daisy chain a lot, is that sometimes you'll go into theaters where they will have installed 70-volt systems for the whole sound system. There was a whole string of educational theaters and colleges and stuff that went up in the 80s that did this. The idea being, we've got students who are prone to breaking things, and if we make everything 70 volt, then they're less likely to blow up an amplifier or something. So they might have little quarter-inch, what looks like quarter-inch jacks all over the walls for loudspeakers, but they're not quarter-inch. The 70-volt connector is just a little bit smaller in diameter than the quarter-inch. And that's on purpose, because they don't want you plugging in line-level devices to that jack. That's connected to a power amplifier, and there's 70 volts on that. You don't want to be feeding that into an input that's expecting like 2 volts. Okay, so it's a little bit smaller, and it looks a lot like this, but that's what it's for. If you ever see that and you can't, trying to figure out what is this for, it doesn't fit a quarter-inch connector, it's probably for a 70-volt distributed loudspeaker system. Okay. Again, not the best idea, quarter-inch connectors for loudspeakers, because the contacts are exposed. And the other weakness is you can only really carry one signal on there because there's only 2 conductors. So let's look at some of the answers to these problems. So in the world where you don't have a lot of money, but you want to solve some of these issues with the banana and the quarter-inch, you can actually use twist-lock power connectors. These comes in lots of different configurations. They're designed for power. This is just meant for a 15 amp circuit here, but this L515 is what this is. But you can get 20 amp, 30 amp, all kinds of sizes of these. That part isn't particularly important for us, other than if you're going to do power distribution, which we do deal with a little bit. Then you have to be very particular about which one you use. But what's interesting about these is they do lock, so you can put them in, twist them, and then they lock in place, which is sort of cool. That's an advantage over a banana and quarter-inch. The other thing is that they are sexed, in the sense that you could have the live end would be this one, which is a female, and it's hard for you to lick that. And this end would be dead, right? You can actually use these for loudspeakers. Okay, wire is just wire. Okay, you just connect up the loudspeaker wire to this, and you've got something that can handle the high voltage. It's sexed, so you don't have to have that exposed live end, and it locks. So you can actually put, the female or the male receptacles could be embedded inside the loudspeaker cabinet, and then this is your cable, and it goes into the loudspeaker, and there you go. It's locking in place. So you might see that from time. In fact, in our theaters, we used to have that before we upgraded to NL4 many years ago. Both theaters in this building, the Thrust and the Arena Theater, were both wired with twist lock for the loudspeakers. That was why, because it was inexpensive and readily available, and it solved some of those problems. And you might still, when you dig around in our shop, you might find loudspeakers here or there that still have twist locks on them, and that's why. Okay. We have some adapters we've built that go twist lock to NL4 and stuff for that reason. Okay. So there you go. That's in the category of when you're doing summer stock theater in a cornfield in Kansas, and you know you've got to get something slightly better than the 1/4 inch. You can buy that at the local hardware store and solve a few of your problems. Okay. All right. So you know, in that point of time when people were doing that sort of thing, what they were trying to avoid is this, which is the EP connector, also known as the AP connector. The difference is the AP is plastic, I believe, and the EP is metal. I might have that backwards. But what these do is they look a heck of a lot like XLR connectors. They're just bigger and can have bigger pins and can take bigger wires. But what's cool about them is this is an EP4. In other words, it has 4 pins on it. And it's sexed, so this would have the live end. Again, can't lick that. This would have the dead end, so this would be on the loudspeaker itself. And then this would be your cable and go in. Cool thing about it, it locks into place as well. Other cool thing about it, you can carry more than one signal on here. So if you've got a situation where you are maybe trying to actively drive that loudspeaker, you know, instead of using the passive crossover inside the cabinet to split the frequencies out to the different drivers, another strategy is you can actually have multiple power amplifiers and split that frequency spectrum out before the amplifier. So you have like an amplifier for the high frequencies, an amplifier for the low frequencies, and then you could use something like this that could carry both of those signals. So you could have pin 1 and 2 would be high and pin 3 and 4 would be low. And then you could run that straight in and drive them directly that way. Sometimes you can get a little bit more sound out of a loudspeaker that way, if it's designed to handle that. This is an EP6, can handle 3 different signals, high, mid, and a low, for example.
How do you designate which signal goes on which path?
It's dependent on the loudspeaker. So the loudspeaker will have this on it, and the pinout will be in the manual or written on the loudspeaker. It says these pins go to high, these pins go. So you just have to patch it on the other end that way. There were a lot of advantages to this, but some of the disadvantages were they're awfully expensive, and they're big and cumbersome to use. But they do solve this problem of locking. They can carry more than one signal, and it solves that problem of dealing with live ends with exposed contacts. Okay, so thankfully we've mostly gotten away from this, but you might see these every once in a while. We have a few here and there in our shop that have these, but we don't really use it. You can still buy loudspeakers. Like D&B Audio Technica, for example, will sell you even modern loudspeakers that they make with the EPs. They're still used in some other countries that haven't quite got to some of the more interesting solutions. This is still out there. It's still a thing. You can take a look at that. So once upon a time, Neutrik was, when people were doing all this EP stuff, Neutrik was trying to figure out a way to solve this, and they invented a new kind of connector. And so depending on who you talk to and how long they've been in the business, they're going to call this a few different things. If they've been in the business for a very, very, very long time, they're probably going to call these Neutriks. Because for a while there, Neutrik was the only one that made it. They were the ones who invented them. But it's, again, not very descriptive because Neutrik makes a lot of things. The product line, I mean, the actual kind of model of this, the make of these is called a Speak-On. Speak-On. That is also not particularly descriptive because there's lots of different sorts of Speak-Ons. And so what we prefer to do is refer to these by their model number. So this particular one is an NL4. 4 meaning that it can handle 4 conductors. And what's interesting about this is this is the cable end, and this is the panel end. So this end would be on both ends of the cable, and this would be on both the amplifier and the loudspeaker. Notice anything particularly interesting about this?
You don't have that?
What's that?
They're both recessed.
Yeah. on either end of this, there's no exposed wires. You're not going to lick this and get shocked. So there's no way to mess that part up. So that's good, right? Another cool thing about this is it's keyed. So there's these little notches in it, which means you can't put it in the wrong way and invert your polarity. It also has this kind of built-in switch on it where you stick it in and you actually have to twist it in order for it to connect up. So putting it in doesn't necessarily make a connection. You have to put it in and then twist it. The advantage there is you know for sure that it's in, right? That's how you know that you've made the connection, is if you can twist it and it goes in there. It also allows you to sort of hot plug these in a reasonably safe way, because you're not going to be able to pull it out until it's actually disconnected from the signal, which is nice. It also has a locking mechanism. So the original mechanism was this ring, okay? And the idea was you put this in, you twist it in place, and then you turn the ring to lock it in place. And now it's in there. And then to undo it, you have to twist the ring back counterclockwise, then turn the whole connector counterclockwise, and then pull it out. So there was multiple steps involved to make sure that you really were determined and knew that you wanted to disconnect it. However, that whole negotiation of the ring and the twist and everything proved to be a little too complicated for us sound engineers who like things simple, apparently. And we had a lot of problems with the ring's not ever getting fully engaged, or you can actually stick it in there and turn the ring and think you're in there, but you haven't actually made the connection because you never actually turned the connector. And then once you put the ring in, you can't turn the connector anymore, right? So there was a little bit of a weakness there in the design, and they fixed that in future versions. So but you still see these from time to time. We've got some here and there, but the way that works is the the ring goes counterclockwise. Well, let's see. I guess it's clockwise technically, if you're looking at it this way. But you turn it to the left to unlock it. Then you stick this in, you twist it, and then you turn the ring, and then it's locked. Okay. So if you ever see those, that's how it's done. So again, later they kind of revised it, and they figured out a way to do the lock without using the ring. And there's this little spring-loaded tab now. And what is really kind of interesting is they managed to figure this out without having to change the design of the receptacle. So this actually still works. So all of your loudspeakers and amps that had this on it didn't have to be rewired, okay, and re-terminated. So this one, you just stick it in, you twist it, and the locking pin slides into place, and it's in there now. And then to get it out, you just have to pull the tab and then twist, and it comes out. That's much simpler, and we could more reliably work with that. Okay. So this is the NL4. Okay. There's also an NL2, which is this guy. The interesting thing about an NL2 is it's the same size as an NL4. And you can put an NL2 into an NL4 receptacle. So yeah, I just did it. That's totally cool. Because what happens is the NL2, what we would call the 1 plus and 1 minus, which is the first signal on there, is the pins there are oriented in the same place as they are on the NL4. It's just that this doesn't have the 2 plus 2 minus. So they're interchangeable in that sense. But you cannot take an NL4 cable connector, cannot plug into an NL2 panel connector, right? Because that would not be very good. So there's something about the way it's keyed, and I still to this day have not been able to figure that out. But there's something about the way it's keyed that allows you to plug an NL4 or an NL2 into an NL4 receptacle. Right? Either of these can plug into this. But if this were an NL2 receptacle, you could not plug the NL4 into it. It won't go in. Okay? sometimes we will refer to these NL4s as NL2s, even though they're technically not NL2s. The NL2 is this one. And you know it because it has a little, instead of the tab, it has the little blue spring-loaded ring. Okay, and it says NL2 on it. We sometimes refer to these NL4s as NL2s because maybe we only soldered up 2 of the contacts. If we're not needing to do an active crossover with multiple signals, sometimes we'll just solder up the 2 and leave the other 2 disconnected. So we'll call this an NL2, and that's really referring to the cable that's on it, not so much the connector itself. We're only using a 2-conductor cable on it, as opposed to a 4-conductor cable. So, for example, when we bought or rented some breakouts from Sound Associates for Guys and Dolls, we asked for NL8, which are these 8-conductor NL series, because that way we could run 1 cable as opposed to a whole bunch, right? And then asked for breakouts that would take those 8 signals and break them out into 4 NL2s. So we asked for an NL8 to 4 NL2s, a tail. But what's on there is actually an NL4 connector. And they called it that too. It's like, well, it's an NL2. It's like, well, it's technically an NL4, but it's just only got 2 wires put on there. So because of that weird issue of the keying of the NL2, you don't tend to see this as often. Because it does cause some problems given that they're keyed differently but look the same. So in most cases, the NL4s are not that much more expensive than NL2s, so most people just use the NL4s and only wire up 2 conductors. And so we've got both in our shop. We have cables that we call NL2 cables and cables we call NL4 cables, but they both use NL4 connectors. There's hooks for different ones. And that's how you know the difference is when it says NL2, it just means there's only 2 wires hooked up.
Why not just have all of our cables NL4?
Because 4-conductor cable is twice as expensive as 2-conductor cable.
Oh.
And so if you're only using the 2 conductors, it's silly to pay for 4. And most often, we're just using the 2. It's the exception is when you're using the 4. So anyway, there are 2 different versions of the NL4 receptacle or panel connector. This is the bigger one. This is the one. This one will fit XLR punch out. It's the same size, but the connector itself is the same. It still goes in there just fine.
That one has metal on it. Like on the, you can see on the outside.
Right there.
So
that
the
just connects up. That's just a. It doesn't actually. That metal doesn't actually connect up to anything.
Oh,
I think it's just to reduce friction. I think it connects up. It's what touches the pin. I think it just reduces wear and tear on it a little bit. So there you go. You can look at those. So NL2, NL4, NL8. They don't get any bigger than the 8. That's the biggest you get. So anyway, that's kind of cool. Those have turned out to be very useful. They solved all of our problems. They were so successful, actually, that Neutrik decided to do the same thing for power. And they created this, which is called the Power Con. And there's we're now getting to the point where we're going to have to stop calling them Power Cons and start referring to them by their model numbers because there's now more than one sort of Power Con. But it looks a lot like an NL4, but there's only 3 conductors in this. And although it's the same size, they're usually, there's 2 colors. You get blue ones and white ones. The idea there is, see if I get this right. For the panel connector, which is this one, the blue panel connectors are hot. No. That's wrong. The blue panel connectors are dead. So this would be on the piece of equipment that needs to be powered. Okay? If you see a white panel connector, like on a wall or on a distribution box, that's hot. So white on a panel means hot. Blue on a panel means dead, live or cold, live or dead. Okay? On the cable, these ones, the blue means dead. Or let's see, no, I got that wrong. The blue is hot or live, okay, and the white is dead. So the idea is you always plug blue into blue and white into white.
So do we need to know the difference? Which one is hot, which one is dead? Or just
Yes.
know blue to blue, white
Yes,
to white?
no, you need to know because on some pieces of equipment, they'll have both a blue one and a white one right next to each other.
But if you have a blue cable in your hand,
Yes, then they're keyed differently, so it will only connect to the blue end. But which end of that cable do you run? And if you're gonna put these onto things, you need to know which one to do, right? If you're gonna make one of these cables, you need to know which end goes where. If you're gonna put these on things and wire it up to actual equipment, you need to know where they are. So if the idea being that if you want, you could actually daisy chain the power. So this would go, this would be live, and then this would go into the device and power it. And now next to it would be a white one, and that white one would now be live.
Mm-hmm.
And so you would plug the white dead end of the cable in, and now your blue end of that cable is hot now. And you can plug it into the blue dead one on the next piece of equipment. Okay, so that's why there's two different colors, is it's meant to differentiate between live and dead. But it only means that if that's how you wire it up.
So just to clarify, white is live?
White is live if it's on a panel. Right? So this version of it that's white, if you see this on a wall or on a piece of equipment and it's white, that means live.
Mm-hmm.
Okay? If you see blue on a wall, a panel, or a device, that's dead. Okay? It's opposite for the cable. Okay? White on the cable is dead, and blue on the cable is live. Okay? And again, that rule only works if that's how you wire it up. So if you're putting these connectors on things, you need to make sure you're putting the right color on the right thing.
No, you couldn't like accidentally put speak on in that, could you? Because that could be bad.
No, yeah, you couldn't. So you could not plug an NL4 into this. It's keyed differently. All right, so that's not possible. They certainly thought of that, thankfully. But it does look similar, I will agree. All right, so there you go. PowerCon. We loved this when this came out because we thought, oh, great, this is the way we can differentiate our power from lighting power and everybody else. And then, we don't have to do that. But then, of course, lighting manufacturers started putting them on moving lights because they're great. They lock, right? And they no exposed contacts, and that's great. All the reasons we liked it, they liked it too. And so we all kind of lost that ability. But we still get the benefit of, no exposed contacts, locking, very clear differentiation between live and dead, all that good stuff. Okay. So you're familiar with this, right? Technically, this is, I think, NEMA 5, but we usually just call it Edison in the theater world. So this is, U.S. power. By the way, they now make 20 and 30 amp versions of the PowerCon.
I've seen ones with like plastic in between the connectors, or in between the contacts to prevent arcing.
Yeah, so that's one of the criticisms of the original PowerCon is that it didn't have braking capacity. In other words, there's no fuse on there, which is weird to me because nothing else in the U.S. powers have fuses on them. So it's really a European thing. But anyway, for some reason, that was UL refused to certify them because of that. So yeah, there's new ones now that have fuses built into them and everything, and better shielding between the connections, the contacts. So anyway, this is why I say we're going to have to start referring to them more specifically than just PowerCon, because now there's several different sorts of PowerCon. Anyway, Edison or NEMA 5. This is usually for 15 amp breakers, power stuff with it. Okay. This is I don't know what the official thing they call this, but this is referred to as 13 amp connector. This is the power connector in the UK. So this is their version of the Edison for us. Okay. It actually has a fuse in it. A fuse that breaks at, guess what? 13 amps. That's why it's called the 13 amp connector. So these are big and wonky, but this is what is used there. So you may run into that from time to time, especially if you go tour anywhere in the UK. Now this started becoming a problem because with the globalization of the economy and manufacturers wanting to market their equipment to multiple countries, it became a problem because all the different sorts of power standards for different countries. For example, that 13 amp would really go, or that 13 amp is expecting a 220, 230 volt power supply, which is more than what we have for traditional stuff. So what ended up happening was now what you have is most pieces of equipment have these what they call intelligent switching power supplies that can take either voltages, right? So it'll work on either system, and it has a standardized power connector from the IEC, which is a global standards commission. This is this has an actual model for I'm not sure what exactly it is, but there's more than one IEC connector standard. However, this is the one we use the most, and we usually just refer to this as IEC. The idea there being is that the power supply and the equipment would get an IEC connector, and then that way the manufacturer could just make one box that would work anywhere. And then it was really cheap for them to just ship with it an adapter that went from IEC to whatever connector you needed in your country. In fact, some mixing consoles and things you might buy will come with like 3 different adapters in them, depending on so regardless of what country you buy it in, you'll get adapters for every possible scenario. So that's much cheaper from a manufacturing point of view than having to manufacture different models of the equipment. So that's how we kind of solved that. There's a downside to this. These don't lock very well into place, and so there's been various strategies to figure that out. A lot of times what they have is a little kind of wire thing that drops down over it to keep it from getting pulled out in mission critical things like mixing consoles and stuff. So that's what that's about. Or servers and stuff, we'll use that. Okay, that is all of my connectors in my box here. That's not all of them, right? There are others you'll run into, but those are certainly the ones you'll run into most of the time. If you run into anything else, you could look it up. But notice that I did all of that from memory. I'm not like trying to impress you, but I'm just saying that that's what I expect you to be able to do. Ultimately, you should know all of these by memory. You should not have to look them up. You should know what these are all called. It's a lot to memorize and a lot to learn if you haven't already. There's probably some things I've shown you that you didn't see before, or maybe you've been calling the wrong thing for a while. You've got to start calling it the right thing, and you got to know what it's used for. Okay, so that's the purpose of the little project, is for you to kind of write all that down in some way that makes sense to you. So you want to know, what is it called? And if there's a difference between what it actually is and what we colloquially call it, you should know that. For example, NEMA 5 versus Edison, you need to know that those are basically the same thing. You need to know, so what is it called? What is it actually? if that's different, if we call it something different than what it actually is. And what is it used for? Okay? What are all the different sorts of things that each of these connectors could be used for? So that when you're working crew on a show and you're trying to assemble one of these things, and they say, "Hey, go get me an NL4 to twist lock adapter or something," you'll first know what that is and have some inkling of what it's going to ultimately plug into. And you would probably think, well, probably plugging in a loudspeaker, an old loudspeaker that has a twist lock on it. We need to adapt it. That's most likely what's going on there. Okay. All right, so that's that. Any questions about any of those? No? Making sense? Okay. So any questions about the project that I want you to do for this?
We need a picture of each of them? Right?
Ideally, yeah. Go and find pictures.
Due by next class?
It's due by whenever I said it was on the thing I sent you. I think it's a week. It's not the next one, it's the one after. So you got a week to do it. This will be this will be a nice piece to show at portfolio review if you look for something to show. That this makes a nice thing to show. All right, how are we doing on time? It's almost 5 o'clock. Tell you what, let's end there because I don't want to do the cable thing in 2 chunks. I'd rather do that in 1 chunk. So since none of you don't have any questions, we can just stop there. And then on Tuesday, we'll do the cables. And in reality, after Tuesday, then I am gone for the following 2 things. So you have more time to do that connector project, okay? Because I'm certainly not going to look at it until I get back. So you don't need to turn it until I get back. So we'll do cable on Tuesday, and then I'll send you on your way for a week while I'm gone, and then when we come back, we'll pick up where we left off.
For this project, you just want us to email it to you?
Yes, if at all possible, I always prefer things given to me electronically. I lose things that are printed on paper. It's a thing I have, and students have learned that the hard way. So I wish I was better at that, but I'm not. So I always prefer something electronic. If you want to do it on paper in a book or something, that's fine. Just take pictures of all the pages and send them to me. Okay. Okay, that's perfectly acceptable. All right.